There we go. Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on Twitch. You know, we don't use any libraries or engines because that is just the way that we roll, and we roll pretty strong here on Handmade Hero. I don't mean to brag or anything, but our renderer is pretty darn sweet, which is actually kind of surprising. It surprised everyone, including me, because I was not expecting it to be this fast without a lot more work. And it turns out that computers are very, very fast these days if you actually just take some time to program them. You don't even have to be that clever, as it turns out. Who knew? We really haven't done anything super finesse-oriented to our renderer, and it's already extremely fast. So I don't know what to think about that. I guess we're just very lucky, and so that's a good thing. But that said, we do have some work to do here, because we're not out of the woods yet in terms of renderer stuff that we might want to do. Today is day 128. And so if you want to follow along at home and you have pre-ordered the game on handmadehero.org, you should unpack day 127's source code, because that is what I'm starting with today. So if you want to follow along with where I'm at, that is how you would do that. So let's open things up here. We are back in our debug build compile, if I'm not mistaken. So we are not compiling for performance anymore, because things are pretty fast now that we did the multi-threading, so we can actually run the game. It doesn't quite run as fast as we would like it to, but we can actually run the game in a fully debug compile. It still runs at a totally reasonable frame rate, so that's pretty fun. So that's all good. So we've got some more stuff that we have to work out. I want to put in here some, just a little bit in terms of notes before we go any further. Because inside the renderer there's some stuff that we haven't done that we might want to consider doing that could have some ramifications. So I just want to put some to-dos in here for things for us to think about. So to-do Casey, and we don't have to do these anytime soon because we've already kind of put things in a situation where we're relatively well isolated, and we could work on this all day long if we wanted to, and it wouldn't really affect the outside code. So that's like a good thing, right? That's where we want to be. So here are some to-dos. One is make sure that tiles are all cache aligned. So like what we're doing right now, oh, and this actually reminds me of something I'll mention on the Blackboard, because someone asked about it and I had no idea what the term was that they were using, because I'd never heard it before. But I actually looked it up and I was like, oh, that thing, okay. So I can actually mention it here because it's relevant. So in terms of what that means with tiles all being cache aligned, right, is that if you want the tiles to be, if we break up the screen into tiles, and our whole purpose of this, right, is to try and make it so that we're rendering quickly, what we want to do is we want to make it, the whole reason of breaking it up into those tiles is to make sure that we can run them on separate threads. So we can have, core 0 takes this one and core 1 takes this one, and whatever. We want to do something like this. And what that means is that two tiles next to each other, we want to be able to support that, very, very easily support that being in a situation where thread core 0 is writing to 1, some core is writing to 1, and some core is writing, that's a different core, is writing to the one right next to it, right? And we don't have any problems with that now because we made sure that we were always SIMD aligned, so we're always 16-byte aligned, and so that's always good, right? And that means that we never have any sharing across this edge, so we can always just load up a block of 4 pixels, operate on them, and write them back, and we never have any contention between these two tiles, right, in terms of our thread code. But even though we don't have any contention that we can see in our thread code, and we don't have any bugs at that boundary that are due to contention, there actually can be some silent contention happening at this boundary. So I want to magnify, I want to do a little magnify here. Let's take a look at this boundary, okay? So we've got all these pixels in here, right, coming through here. And we're operating on, these 4 pixels here on core 0, and we're operating on these 4 pixels here. Oops, that's only 3 pixels. These 4 pixels here on core 1, let's say, right? Well, as we know, and we haven't talked about this too much, but there's something called a cache line, and maybe this is a good time to be more explicit about what that is. A cache line is the unit at which the cache caches memory. So, if your cache lines were 4 bytes long, right? Let's say, in the hypothetical cache, that would mean that every time you looked at a memory location, right, it would be looking to see if you hit somewhere inside a 4-byte long region that is the place that is, stored in the cache. And if you weren't, if you're outside of the things that are stored in the cache, right? And who knows how many we have of these, right? Let's say the cache has 1 megabyte of data or something. Well, that's a little too big. Let's say it's 32K, right? If the cache is 32K, that means it has 32K divided by 4 cache lines in it, and each one of them has 4 bytes, right? And so it's going to look and see, is anywhere in the cache, does it have the piece of memory that I'm trying to access? If it does, it goes, okay, great, and it tries to remember the fact that it used that recently, so it doesn't evict it. If it doesn't, it goes, okay, try to evict someone from this cache, take one of those 4-byte lines and put it back out to memory if it's been modified, and then load in, from memory, grab in from memory the 4 bytes that are actually being asked for, and now they're in the cache and they can start being worked on the cache, right? So a cache line is just like how big that chunk is in the cache. A cache line is one of those chunks, and 4 bytes is way too small. I made that number up. You're talking about something much more like 128 bytes or something like this, right? So depending on your processor, you have a cache line that is some size, right? And that is the unit of granularity at which memory will be pulled in. So the reason we care about this is that cache lines are the things that actually get arbitrated. Remember when we talked about MESI, right? Modified, exclusive, shared, invalid? Cache lines are actually the thing that preserve memory coherence between multiple cores when multiple cores are working on things. And so as long as the cache lines ended right at the tile boundary, we would never have any contention for cache lines between the cores, right? We'd never have anything going on there. They would always, like, this would be one cache line, right, that ends right here, and this would be another cache line, right? And these two cores could just party on it, and they never have any contention. But if we did not happen to end right on a cache line, then that means there is a cache line that, like, spans these things. So let's say that the cache line, spans these things. So here's a cache line. Well, yes, we don't have a bug in terms of contention because the processor will always take care of it for us, but what will actually happen when we're working on these things is when we go to load this cache, this piece of data, right? When we go to load that, it's going to pull it into Core 0's cache. And Core 0's cache is going to be marked as shared or something like this, right? Then, Core 1's going to hit it, and he's going to pull it in, and it's going to be marked as shared in his cache or something like this, right? But then 0's going to try to write to it. And when 0 goes to write to it, it's going to mark it as invalid in this guy's cache, right? And it's going to mark it as modified in this guy's cache eventually. So now what happens is when 1 wants to write back his result, he then has to go re-pull that data into the cache again. Because his copy is now invalid and he knows that he can't actually write to it without first grabbing it from whoever had modified it. So it's got to go snoop it out of 0's cache, and then it's going to invalidate it in his cache because this guy's going to modify it. And so but this cache line is like bouncing back and forth between the cores potentially. Who knows what's going on, right? And so we actually want to make sure that we don't have this happen. We want to make this happen. We want to make sure that these guys are not actually going through a bunch of contention internal to the processor, even though we are not seeing it external, because that could have performance ramifications for us that we don't want. It will lead to us having more memory traffic or more cache, people talking to each other in terms of on the CPU, and that could lead to slower performance than if one CPU core knows it can always just fully monopolize that cache line, right? So I'm not saying that's a performance concern right now. I'm just saying that we don't know that it isn't, and it could be. And so one of the things that we want to test later is making sure that we cache align things and see whether that improves our performance, because that may be important. So there's that. The next one is, can we get hyperthreads synced so they do interleaved lines? Because right now we're not using hyperthreads at all really in any particular way. We're not trying to account for that. And it would be nice if we did something with hyperthreads where we could do interleaved lines. The reason I haven't done it yet is it's not immediately obvious to me how to synchronize things so that people pulling, hyperthreads will both pull the same work unit out or something like this, and just do even and odd pairs of that work unit. So I don't actually know how to do something clever like that. And so I might talk to some friends and see if there's any way to really do that, or it might be that that's just a bad idea and that was stupid and I shouldn't try to do that, and in which case we don't have to. But I wanted to mention those two things. And then finally we want to know, like, how big should the tiles be for performance, right? Because how big the tiles are affects how much of the render target stays in the cache. And we may be doing some read, modify, write to that render target often, multiple times, like if we're layering things on top of each other or who knows what. And so in that circumstance, we have to consider how big the tiles are makes a difference in terms of performance. Making them smaller means that more of it fits in the cache, but more work has to be done in setup, right? Because remember, every one of those tiles has to do work to like figure out where all the blocks are relative to it and clip them and all that stuff. So there's work being done in dequeuing the thing and all that stuff. There's work. So it's not free to make the tile smaller, but there may be benefits in terms of performance in the renderer to making them smaller. So we want to see if we can figure out where that performance trade-off leads us in terms of what is a good tile size to pick. So there's that. So I just wanted to kind of put those in there now, and maybe sometime when we're feeling like doing some more performance, we should play with that, because that's basically what we have to do in terms of doing some checking on the performance. And then we also want to do a couple other things here. We want to do like actually ballpark the memory bandwidth for our render routine, for our draw a rectangle quickly. So we want to do that actual ballpark there. And we also want to retest some of our instruction choices once we actually have, now that we've got multiple threads working and stuff like that, we would want to go actually do a little bit of playing with the actual optimization of that routine. Once we now can sort of see, here's the actual fully hyper-threaded use case once we decide to do that. So we've got some of those things to do in there. Okay, so I don't really want to tackle that stuff today. What I'd rather do is start to clean out the renderer a little bit more in terms of some of the sort of things that we left as loose ends. So before we actually start to tighten the ratchet down on this, now that we've got it running, I think what I want to do is just go a little bit further in terms of getting the renderer into sort of a more complete feature set, if that makes sense. So that we don't optimize stuff that in absence of knowing exactly what everything should be doing. So what I want to do in that effect, and I guess we can pop over to the to-do list here. So what we want to do is finish straightening out all the coordinate systems, which we kind of did. We actually did a bunch of optimization now as well, which is kind of cool. We're actually running very fast. So we want to straighten out these coordinate systems. So I want to go through and do that pass. I want to get back and sort of finish up that lighting, right? And then we'll do the final optimization. And then we can kind of cross rendering off the list. What I might want to do as well in here is some particle systems, because I feel like particle systems might want some consideration in the renderer as well, because they tend to be a little bit different from other things. So I would also like to do a particle systems, a brief little particle systems thing in there, perhaps before we do lighting, or perhaps after. Not sure where that should go. I don't really know. But then we'll have to do that final optimization pass, and then we can kind of call the renderer essentially done for all intents and purposes. So I think that's a reasonable idea. That seems good to me. And I'm going to take a quick look here to see what we have to do in terms of other stuff. So I feel like we probably want to move audio up here as well. And I think we want animation up here as well too, probably. Maybe not. All right. So I think this is basically going to be mostly sort of game stuff, right? This is sort of, in fact, I feel like this stuff is kind of getting straight into game stuff, most of this stuff here. So this stuff here is kind of stuff we can make and put away. So I want to sort of concentrate on getting this stuff finished up, because this is basically, you know, the low-level engine stuff that once we have it done, we can probably call it, you know, pretty much done. So yeah, so I want to try and get through some of this, and maybe look towards trying to get the renderer actually shipped sometime soon, so that we can check it off our list of things that need to get done before the game can ship. So let's take a look at how we were doing with our coordinate systems here, right? We had our render group, and we're pushing things onto the list, and we kind of have things that are a little janky here, because we were just sort of pushing things on sort of willy-nilly and not really thinking too hard about how this stuff wants to work. And so what I think I don't like about some of the stuff is this render entity basis stuff and these sorts of things. I feel like there's a little bit too much going on there that isn't necessarily stuff that we need to have happen. And similarly, I feel like we are playing it a little fast and loose in terms of how we're actually dealing with our camera stuff, right? So I kind of want to take a look at this and maybe make it a little closer to how you would typically do it in a 3D pipeline, so that I can be a little bit more comfortable about how it's all actually working, right? So let's go back and take a look here, right? At how this stuff is actually playing out. You can see we've got this this basis function, this get render entity basis, and what this does is this basically does our 3D transform, because even though we're in 2D, we're actually doing, you know, most of our stuff in 3D, and you can kind of see us going ahead and doing that here, right? And so what I'd like to do is go ahead and make this a little bit more formalized, because what we have a sort of a problem with at the moment is we don't actually have any way of saying that we don't want to do any sort of 3D stuff, right? And that kind of reared its ugly head at us, because what ended up happening when we wanted to build the ground chunks is there's no way to actually go and disable this situation where we are doing these 3D transforms, right? And that is a problem because we can't make our ground chunks seamless like we were doing if we don't know that we're actually operating in proper pixel space and that sort of stuff. So I think that this is mostly what we want to focus on here, is actually like, you know, doing some work here where we can make this a little more solid. I guess that's what I would say. So what I want to do is make it so that we have a way to do both an orthographic transform, a standard transform like we were doing originally, where we just can place things pixel-wise. I want to be able to do that, and also I want to be able to do the perspective transform in both cases. So the way that I want to approach that is I want to stop doing these delayed, and I want to start doing them right in line. And what that's going to require is, if you remember the way that we were doing this, we had it so that when we went through our entity simulation, which was happening in here, right, we would simulate the entities first by executing what was ever in their switch statements here, and then we would just sort of put on whatever we wanted the bitmaps to be that they were going to have that were related to them, right? And then after we were all done, we would do this thing where we would simulate the entity, and the entity would move to wherever it needed to move or whatever, that sort of stuff, right? And this created a problem because it meant that we couldn't actually know where anything was until after we already finished our simulation switch statement, And that was just really annoying, and that's what caused us to have the delayed render entity bases, stuff like that. So in general, I don't really think I like that idea, and I don't really want to do that anymore, right? And so what I'd rather do is I'd rather have it so the entity gets moved and then the rendering for the entity happens. And we can really do that in one of two ways. And I'm going to do the simplest way right now, but we may do something a little bit different a little later on. So all I'm really going to do here is I'm just going to copy the switch statement, right? And I'm just going to have half of it be in render, half of it like out here, I want to be the render part, right? So this is like, you know, render an entity. And the other part up here, I want to be simulate an entity. And I think eventually, I don't know, eventually we may still be able to do these together because we may have the way movement works be a little bit different. But I feel like, in some sense, I maybe don't even want to call it simulate an entity or move an entity. I think what I probably want to call it is more like pre-physics entity work, maybe would be a better idea, and post, right? And so, you know, we might even do stuff that is actually not just rendering in this backend here, right? And so, you know, I just kind of want to, I want to make it clear that simulation could happen in here. And so what I'm going to do for the moment is I'm just going to do, again, the simplest possible thing. I'm going to just go ahead and kind of make this stuff work to the extent of just splitting it in half. And that's it. And then what I'm going to do is go up here and remove the, remove that code. So that's gone now. Walls don't need any sim. Stairwells don't need any sim here. The sword does. And then we've got our familiar. And our familiar does have sim, but then it stops here. And the Monstar has no sim at the moment. And let's see, space has no sim either. So we're only simming a couple entities at the moment in terms of stuff that they actually do. And then we do all the rendering here. And so what I think can happen now is we can go ahead and actually just put things at the location where they actually should be, right? And so now, instead of having to do this stuff delayed, we can just do it right in line. So when things get pushed, they will just get pushed properly, right? So let's take a look at that here. What I want to do is say this default basis thing. I'm going to actually make that be something that's just kind of set directly in the render group and used as sort of a thing that kind of gets overwritten and stuff like this. So I'm going to have a default basis there, and I think what I would like to do. How do I want to do this? I think what I want to do is I want to look and see what we're actually using in here out of that basis. So let's see, entity basis. So we use the P, screen dim. Screen dim probably also wants to be something that's sort of in there as well. It looks to me like, so I feel like we're going to want to do that monitor half dim in meters sort of situation. I'm going to want to pull that out as well, I think almost certainly. Then we've got, let's see, so the camera's distance above target, and the, let's see, and the focal length. And it looks like that's about it to me. Yeah. Of course, you got the near clip plane as well, but that looks like basically it. Yeah, so I'm going to go ahead and just, again, do the simplest possible thing here to pull this out. I'm going to sort of, do we use meters to pixels in here as well? Meters to pixels? We do. So we have meters to pixels as well. So I'm going to go ahead and sort of pull these out into that render basis, right? Which I guess will actually, I might just call it this. There we go. And this render group camera, I'm actually going to call this just a render group transform for now. And I'm going to use this render group transform, and I'm going to say that we basically have one of those, right, like so. And I'm going to get rid of this concept of game camera and render camera in here, right? And I'm going to have that be something that's actually done outside, right? So we're going to have that be done outside. So here is our transform. This is our current transform. And it is going to contain all of the stuff that we need for this. And so this routine, get render entity basis P, is actually just going to kind of collapse away into the thing that actually does the push. So I'm going to put this entity basis P result thing, I'm actually going to sort of get rid of that concept a little bit, right? And we're going to kind of move it down to where things are getting pushed. So here where things are getting pushed, I'm going to have that be the place where this stuff happens. And so when we actually were doing that up here, like when we're actually doing the get render entity basis P, what I want to do is I want to do that all at push time. So instead of having that be some delayed thing that transforms things after the fact, I want to make this actually something that happens at the time when you actually submit it. Okay. So at the time when you submit it, I'm actually going to call this, so we're going to have this guy come down here. So when you call, draw rectangle or push rect or any of these sorts of things, right? So we do push bitmap, for example. What this is going to do is it's first going to actually do that transform, right? And then it's going to see if that the transform, if it can actually be seen. And so what will happen is, the nice thing about this will be if this thing was like behind the camera or something, it won't even ever get pushed onto the render stack. So it just gets thrown away immediately, which is kind of nice, right? So we'll do that. For this guy right here, I guess the same thing. Is that how these guys worked before with the rectangle as well? Yes. So these guys work the same way. So similarly, like I can do the exact same thing when you push a rectangle, right? We can say if the basis is valid. There we go. If the basis is valid, then we would do the push. Otherwise, we just won't ever do the push. Push rect outline is just exactly the same thing, clear. And then our coordinate system needs to do the same thing as well, right? It needs to do this as well. So all these guys basically just have to do this, this system here, right? And this is now going to be something that might return a 0, if that makes sense. And so anyone outside who calls it would have to do that. Now this is our test call anyway, so I'm not super concerned about that. But just to be safe, when we actually do a coordinate system here, I'm going to do a thing that says, if C, like so. Actually, do we have a reference C anywhere at all? C arrow? We don't. All right, so that doesn't actually even matter. Never mind. Never mind. Nobody cares. Nobody cares at all. So we'll just go ahead and get rid of that. Like so. In fact, we could, if we wanted to, just get rid of this entirely. Okay. So yeah, so hopefully you can see sort of what I'm doing here. I'm just sort of pushing this work into a different location, and I'm pushing it to a place where it can be done, right at the time. And I like that a little bit better because then we're not wasting this time of like going back and retouching things to recompute them and storing more data than we need to. So, all right, so when we come through here and we're going to look at our render entry bitmap, we're going to make sure that that now stores the correct stuff with it. So I want to just take a look at what that's got. Render group entry bitmap. So we have our loaded bitmap, and our entity basis can now go away. And we only need to know basically whatever these two things were. So we just need like it to store the P and the scale that would get used. It looks like that's about it. And so that's fine. Now, I guess I don't understand exactly entry size. Why is there a size and a scale? Yeah. Does anyone know why we still have a size and a scale? Does that make any sense? I don't know. I'm going to say that it doesn't make any sense. And so I'm going to go ahead and say that this would just be like that. Because since the scale is not actually used anywhere, it just doesn't seem relevant to me. Now, it could be that since we normalize them in the routine, that we should store a scale plus already pre-normalized, but I don't know. I'm just going to go with this for now. It just seems silly to have more. So inside the render the bitmap information, you know, all we would have is that 2D position and then a size. We may eventually want to store the full 3D position for lighting purposes or, you know, something like this. So I don't actually know if we want to, you know, we may want to do that a little later, but for now I'm just going to store only what we're actually using rather than try to like guess and see what we would use later. So we would need to store the P there, and we would need to store the size pre-scaled there, and that's fine. So that all looks good. So the same would go for these guys. The render entity rectangle would now do that plus, I guess the dim there would now be pre-scaled, so we wouldn't have to call scale on it. And so I think that was just all there because we weren't doing the transforms in line. I think we can basically just get rid of all that now. So this stuff we now totally got rid of. I guess we're not even calling it anymore because we haven't been testing with it. So I'm going to go ahead and compile that and see where we're at. So pixels to meters, where does that actually get used? That gets passed into these guys. So draw a rectangle quickly. Let me take a look at what's happening here. Those, I guess, are just used for our positional lighting stuff. I assume is the only thing that that's actually used for, looking up into that reflection bitmap. So I guess that can change is the only problem, right, for the lighting. That can actually vary. So I feel like we need to store that with any particular render entry as well, because it's part of the lighting equation. At least that seems like what would be the case to me. That's what I feel like. So let me take a look here also at screen dim. What's happening with screen dim? So screen dim's only getting passed in here, so that we won't need either. So that can just go away, actually. That can go away entirely. And so that's good. All right. So it's really just this guy here. Pixels to meters is actually something that's going to have to be stored. It doesn't have to actually be stored for things that don't have lighting, like the render entity bitmap, which doesn't have lighting. Doesn't actually need to be stored, but it would need to be stored for other people. Like, for example, the coordinate system would need to store meters to pixels in it to do the lighting. So when we think about that, we'll have to think about how we want to do that. Need to store this for lighting. Let's see. I'll put it like that. Okay, so we come through here and we do our rectangle drawing. We do our draw rectangle slowly and our draw rectangle quickly now can both work okay. Pixels to meters for draw rectangle. It's weird that draw rectangle slowly, it's taking a different spot. So draw rectangle quickly and draw rectangle slowly. They don't actually need those quite yet. What the heck. I guess I'll go ahead and put them in there. Because eventually, I'm really torn. Because we're going to want a draw bitmap that doesn't use lighting. So I'm not going to do that. So I'm gonna put like null pixels to meters or something, right? And I'm just going to have null pixels to meters is just 1. There's no transform. Okay. So that should be fine. Let's take a look here. The entry, render entry rectangle. Oops, I didn't actually add that in there. I kind of want these sorted like that probably, don't I? I feel like I do. Okay, and this doesn't need a render entity basis anymore. In fact, nobody needs one of those. In fact, render entity basis can actually just go away. And let's take a look here. So now what we need to do is we need to initialize some of these things. Like our default basis is gone, but we do have the concept of that transform. And the transform is going to have some of this stuff, right? So what we want to do in our transform, we probably want to have, again, that scale, and we want to have an offset in there, right? So we'll leave that like that. And yeah, I think that's all good. So in here, in the transform, we need to initialize all this stuff. So it's doing a push struct of a render basis. I guess it doesn't need to do that anymore because the render group now just contains it directly. So actually, it doesn't actually need to do that. It can just do render entity transform directly without ever having to do that. But it needs to be able to put meters to pixels in there, right? And it needs to be able to, oops, didn't really want to actually initialize any of those. Meters to pixels needs to be in there. And monitor half dim in meters needs to be in there. The focal length needs to be in there. And the distance above target needs to be in there. Offset P, and the scale, right? And what we probably want to do, I'm just guessing, is to start with essentially an invalid transform. I'm guessing. I don't really know. I'm just guessing. Well, I guess we could set it to something sort of reasonable here. Let's take a look. So in here we'll say, okay, we've got the monitor half dim in meters. We know what that is. It's right here, right? We were already computing it. We've got meters to pixels. It's right here. So that's good. Let's see. We've got a to-do in there, justice based on buffer size. So that's something we'll have to do. That's still not being done. So we've got focal length, and let's go ahead and copy that down. All right. We've got distance above target, and we've got width of monitor is just something that needs to be dealt with a little bit more specifically later. Offset P is going to be nothing, and the scale will just be 1.0. Is global alpha used anymore? We still using that? Yeah, we still are using that. That's what we're using to do that silly fade thing. Yeah, okay, it's fine. So I think that's everything that needs to happen there. So that all gets initialized properly, right? So that's good. And I think now, when we call get render entity basis P, let me see what render group actually, oops, that's not at all what I wanted. Okay. Let me see what we actually call, what we actually get out of render group. Do we get anything? So we need the focal length, but that's okay because that's now in our transform, right? So we need the focal length, we need meters to pixels, which we have, right? And we have distance above target, right? And then we also have screen center. So screen center is just transform monitor. That's monitor half dim in meters is not actually, who actually is using that? Monitor half dim in meters. Get camera rectal. Okay, so that is actually a mistake. That that I didn't mean to pull out. That actually stays in here. So that's monitor half dim in meters. That's a different thing. Got a little overzealous there. So that actually wants to stay up here. So here we go. Note Casey, default transform. And so what we want to do here is just have screen center, like so. So we want screen center. And we want screen center, I assume, will just be this for now. Right? So we'll leave that like that, but of course we can always modify it later. So the transform's got that in there now. And so if we pass in a transform here, and render, let's call that just render transform. I don't think we need to be render group transform. So if we said what the transform was here, right, like that, then really all that has to happen is we just need to take in that the p value there, right? Because entity basis was only used to get that p value, right? So there's the offset xy. Yeah, I mean, this is just a 3D position now, right? So entity base p is this value, right? And then entity base p is never actually used again. So we really just have a p value, right? There's nothing wacky about it. So we should just be able to do this, right? We should just be able to go ahead and get the p value in directly. And if there's some kind of z offset that someone wants to do, they just wouldn't pass it in here, I assume, right? They wouldn't consider it part of the get render entity basis part of things. So I think that's fine, and we can just say, okay, this is just pz, right? And this is just pxy, like so. That seems good to me. I don't actually know why raw xy gets constructed as that value. Okay, because we wanted to see what the actual scale was, so that makes sense. So I think that's all good. That looks pretty reasonable to me. Let's reorganize this a little bit here. Screen center is now part of the transform. So that looks like this. And now we've reorganized this routine to a reasonably good, situation. So we compute everything off of just the transform, and off we go. So that seems pretty reasonable. What that means is, though, this actually has to have screen center in it, not monitor half dim in meters. That was just wrong. And then when we do the entity basis p result, right? When we have that happening, what that's going to do is we're going to pass that now different stuff. We're going to pass it the group transform, right? And it's going to use that. And then what we want to do is we want to take the sort of the position of this thing. We want to take that in as like a p value here. Now the question is, do we want an offset in addition to the p value? Because we could have an offset that gets passed in that's not part of it, right? I don't know if we want to do that anymore. I think we were kind of up in the air as to whether we were going to do that or not. But you can see where we would kind of do it in here if we wanted to. But anyway, so we're going to go ahead and put that in here like this. I guess you know what I also have to do, which I forgot about, is this p value here. This p value has to be adjusted based on the transform, right? Because the transform has an offset in it, right? And we're not actually using that right now. So this is like a p, original p, and so we do actually still want to do that sort of stuff where we go original p plus transform offset p. So that allows us to move everything around with the transform if we want to. Let's see. let us see here. All right. So that's all good, I think, for the most part. Let's take a look. Pixels to meters. Pixels to meters. Where did my pixels to meters go? I accidentally deleted it, didn't I? Horrible. Horrible, horrible, horrible. Why did I do that? All right. Well, meters to pixels. There we go. Pixels to meters. And there we go. Okay. I guess I could also do a safe ratio 1 here, just to make sure in case some weird, totally bogus values got passed in. And let's see. So transform does not have an overloaded. You're right. It does not have an overloaded arrow operator because it's right in there. There we go. And we've got, let's see, offset P needs to be all zeros in a vector. It's not a scalar value. And, oops, in fact it's, oh, although it should be. I don't know why it wasn't a vector 3. You should be able to offset stuff however you want, really. All right, so that seems fine. Push bitmap, entry bitmap. That was just a, that was got, I think, a cut and paste error there. That should be up here, right? That should have been this, I think. I don't know why I accidentally cut and paste the whole thing. So we come in here, we do push bitmap, we see whether it's valid. If it is, we come through here. We need the size again, like our size now needs to be scaled. So we have that that basis that comes back. It's got the scale in it, so we can go ahead and multiply that. And then when we store the actual p-value, right? Offset minus v3 align. Okay, so we need to do this stuff. Here we go. So we need to do this computation up here, and then this is our actual p-value that we're using, right? Here's our p-value that we're using, and I guess this is technically offset, right? So we need to do that alignment of the bitmap, which is fine, right? Looks like we're just trying to align the bitmap there. So we do that alignment, and then that's the thing that we're actually going to transform. So we transform it, and then we actually just store that p-value now instead of doing anything fancy, right? And we don't need the scale anymore because the scale will just be baked in to the size, and the size wants to be multiplied after the transform. So I think that's all correct now. That will just basically do exactly what we did before, but it does it right now instead of waiting, right? So here we have same situation, group, we've got the group transform, and then we pass the offset. That does all of our camera work for us. We then go ahead and say, excuse me, So I guess we actually want to do this first, right? Yeah. So we want this to go ahead and happen first. We want to say, here's our p. This was the p-value that we were going to use, like so. And then we want to actually, instead of, we don't want to store this, in here, we just want to store, I don't know why this is called piece. That seems kind of dumb. Let's go ahead and change that. So we want to go ahead and record the scale and the result there. And this is going to take in that value. So I think that's all good. That again we're just trying to reproduce what we had before, but do everything in line. So here's the push bitmap. We don't store the basis anymore, so we can just get rid of that entirely. Let's go ahead and see that. Coordinate system. So coordinate system we're not really doing anymore. We'll deal with that when we get to it. But I think we have 10 minutes left on the clock. If I remember, we started 10 minutes late. So I'm going to go through so I can finish up these code changes. Okay. So when we do this stuff like unproject, so unproject should now do it with whatever the transform is that the group is using, right? It should unproject with the current transform. So that's just going to be doing this, like so. Oh, well, So this is why we had the debug one, the debug camera and the regular camera in the renderer. So I got rid of that, but I wonder if we still want to do it, because if that's the way, I wonder if we want to do it this way, where we still do the two transforms, and when we push them on, we change things. I'm not sure if we want to do that or not. It's a little dicey, right? Because as we are editing those, adding in sort of that distance above target, it's really the distance above target and the offset are the only things we would be changing. So I think I want to do that slightly differently. I think I want to do that slightly differently. So I'm gonna leave it like this for now, and then we're gonna re-enable that later. So we're gonna leave it like this for now. So let's go ahead and keep going here. We've got the transform that needs to be accessed here. And then we've got the render basis. Let's see. So we don't need to do this anymore, right? This stuff is actually not that necessary. So when we push on these render bases, what we can do now, instead of having to do this, we can just actually pass these values in as the actual things that we want to use, right? Because they're not necessary at all anymore, I don't think. So where is the default basis equals basis? Where is the actual? It's just pushing a random one on and putting in that delta. So I think we can literally now just do this, right, for these guys, like so, and not have to do any of this stuff. That stuff can just go away, which is good. But we will need to set up. So we'll need to do a thing here where we actually set up the camera more appropriately. But I think that's basically it. Okay, so let's see. We got the render basis stuff happening here and going to 0, 0. Again, none of that actually needs to happen anymore. That can just be cleared out. So that's good. And none of this stuff needs to happen either. That can go away, right? And then here, so really all that this is doing that transform to put things into the correct position. So all we would really have to do here is go ahead and set the render group, right? Set the transforms P, offset P to be whatever the ground point's location is, right? So let's go ahead and do that. Now we probably messed a bunch of things up, and that's totally fine. Oops, it's a dot. What is this saying? What is wrong with my render group? Transform must have a class. What did I do? I want to access transform from my render group. Left of transform must have a class struct room and type is render group star. Oh, so it was a pointer. I guess it was only complaining about this one. My bad. So I don't suspect that this is going to work at all. Well, how is it possible that every time I think there's no way something is going to work and we make a ton of code changes, it totally works? That's just weird. Okay. Well, I guess it worked. All of those changes, and it worked right the first time? Okay. I think there's still something wrong, though, because you see there's that orange. I don't know why that orange thing is there, so I'm not sure what's going on with that exactly. So there might be something strange happening there. I don't know. That's probably just offset stuff. Anyway, I am shocked that worked. We should have at least had something serious go wrong in there. We didn't. That's good, I guess. But that is, yes, very strange. So what I was going to say before is I was thinking that perhaps what I should do is I should make the render transform stuff work a little bit differently for the debug, where it would just take distance above target, and if it was in a debug scenario, it would add to it. I'm not sure if I like that or not, but I'm trying to think of a way. I want people to be able to work with the transforms and be able to work with them directly, and they only get modified in a debug scenario like after the fact. So I'm not totally sure what I want to do there. I'm just not totally sure. But I think what I was thinking is something like taking this distance above target and saying oh, okay, distance above target equals that, right? And then this could be picked out of a different location, right? So distance above target could actually be modified in some way. If debug camera distance above target, we're much higher than we would normally be, or something like that. Stuff like that. I don't know if that's a good idea or not. I'm not sold on it. But that would be one way of getting our debug camera back, right? So yeah. So that's all fine. Yeah. Yeah. It's kind of funny watching the little dude walk around in here. This is going to be a pretty sweet game engine, I gotta say. Since it does everything without much in the way of the limits, it's going to be kind of fun. I wonder if anyone will ever actually play a world that's huge. I suspect, I mean, I don't know, I'm just thinking this is probably true. I don't really know. But I suspect that if we make it so that you can say, I want you to generate me a world that will take me 6 months to complete, somebody at some point will do it. Like one dude or something. But yeah. Okay, so I'm going to put a little to-do in here. But we want to keep that going. All right, so I'm going to go ahead and go to the Q&A. I think we're right a little maybe 2 minutes early, but that's fine. I'm going to go ahead and go to the Q&A and take any questions. I think we've got everything organized relatively well now. And so that's good. That'll allow me to kind of go ahead and now go through and finish up the rest of the coordinate system stuff, and it'll be pretty in line with what we would want to do for hardware rendering as well. Please remember to prefix your questions with Q:, so I can see them, by the way. No questions today. Everything works the first time because you think out loud. But not everything works the first time. That's the thing. Oftentimes stuff doesn't work the first time on the stream, but they're not the things that I think are not going to work the first time, right? And then when I do think something's not going to work the first time, it does, which is odd. I guess that's just because my brain is thinking something's complicated, so it's paying more attention to it and is less likely to screw it up than in the case where it, well, I don't know. Let's see here. Does the yellow part represent the loaded bitmaps? Well, so yellow was just what we were writing in there because we were for ground chunk purposes. I can turn those back on actually. In fact, tomorrow we can turn those back on permanently. I think because we will no longer have the problem of having to turn them off for testing purposes. But they're basically this fill ground chunk thing. That's what the yellow is. It was just showing where those things were not happening at the moment, right? And so these guys, these things, right? So we are kind of in a position where we need to. They were sort of the big. They're the big thing that's left in the engine, not the ground chunk specifically, but like the sorting and the depth stuff and how we deal with those Z's. And how that all ties into lighting is like the big is this the only real giant thing left in our to-dos, if that makes sense. So yeah. So I need to fix the 2D. So I did break something when we went to it, which is that I'm treating the Z offsets all the same now, which I guess we don't want to do, right? Because you can see the head as it floats up and down, it actually is moving, it's moving laterally as well, which I think we were saying we didn't want to do, but I don't know. I go back and forth on it. I never really know what we want to do or what we don't want to do, but we'll take a look at it tomorrow. These guys are placeholders for a stairwell. So yeah, but we wanted these things to be, I think, to stay on top of each other was the idea. So yeah, so I'm not sure what we're going to do with that. It's going to be dicey. But I really love the scaling. I love the scaling so much that we're going to figure out a way to make it work with the art. I don't know what we'll have to do, but we'll figure it out. Because I really want to be able to walk up and down a stairwell and have stuff get bigger like that. It's just too darn cool to not have. So I feel like we have to have it. What does it mean to invalidate cache? You'll have to take this explanation with a bit of a grain of salt because I am not really that knowledgeable about CPU hardware these days. I really just don't know very much about how it works internally. So I can only kind of give you a sort of rough overview of what probably happens, and if you really want to know the exact specifics of any of it, you will have to do additional reading, I'm afraid, or ask someone at Intel for a good explanation. So what happens with the cache, right? Let's say we have core 0's cache here, right? And I'm not going to draw L1 and L2 and L3. I'm just going to say that we have, two caches of some kind for these cores. Because I'm just trying to give, like I said, I don't know the specifics well enough to make explaining it at that level of detail worth anything, because it would still be just more hand waving, right? So here's the CPU, and here's a register, right? So typically what we're going to do is we're going to issue something like a move instruction. And the move instruction is going to grab something from the cache, and it's going to bring it into the register of the CPU. It's going to be worked on here, and then it's going to go back out, right? So what happens in this actual scenario is that main memory is what actually stores the definitive contents, right, of stuff that is not in the cache. So there's a lot more here. This is 16 gigabytes or something, right? And this cache is maybe only 256K or something, right? So this is very tiny, right? And here's another 256K. These are very tiny compared to this thing. Okay. And so here's, I shouldn't say CPU. I should say, in fact, I don't really know why I drew it this way. This is a dumb drawing. Dumb drawing. All right. Try that again. So here's core 0 register, right? And here's core 1 register. So what happens is you go out there and there's some location in memory, and let's call that location A. So at some point, the CPU says, I want to move location A into this register, right? Core 0 says that. So it goes out to the cache and it asks the cache for location A. It's like, I need to load location A. And what the cache says is it's like, oh, I don't have location A, right? So it goes out to memory and it grabs location A and it brings it back in here and it sticks it in here. And now the contents of location A live in here, okay? And it marks it with some flags. It knows that this is a value that's potentially shared, right, or something, let's say. Maybe someone else has it, I'm not sure. It could be marked as exclusive when I bring it in because nobody else has it, I don't know, right? So something happens here. It's marked with those flags. These are the mezzi flags I was talking about. So it's marked with some flags when it first gets loaded in. We have location A, and then it says, okay, now I can give you location A, and we put it into the register. Now what happens is core 1 also wants to do that load. So it goes out to its cache and it says, hey man, like I need location A. And it doesn't have it either, so it goes out and gets it from here, right? Actually, I guess that's not true. It first does a snoop to see if anyone else has that in, I suppose, without going to main memory, and it finds that cache 0 has it, is what actually would happen. And presumably it would get it from there. So it would get it from core 0's cache, it would stick it into here, and now these guys would both be marked as sharing this cache line, right? So they're both sharing it. And what that means is they can both operate it on it just fine. Everyone's reading from it. They read from it lots of times. They move it into a register. They do some stuff. They move it into a register again later. Who knows what they do? But then what happens is somebody writes to it, okay? So core 0 goes, I need to move something to location A. So instead of moving from location A, I'm moving to it. I'm not moving from it, I'm moving to it. What happens then is the cache goes, okay, well, unfortunately, I'm sharing cache line A, I'm sharing memory location A with a cache line in core 1. So what I first need to do is I need to announce, essentially, that I'm going to write to it. So what happens is I change it to exclusive, and I let everyone know that I've made it exclusive, so they now get it marked invalid, okay? That is what is meant by invalidating the cache line. It's saying this cache line, this thing that I've got stored here, no longer accurately reflects what the location, the value of location A is, as far as the CPUs are concerned in this machine. This core then go ahead and writes to it, which changes it from E to M, which is modified, right? So out comes the value, the new value gets placed in here. And then the next time core 1 goes to read from this, it goes, hey, give me that cache line, and it goes, sorry, my friend, cache line A is not in there. I gotta go get it again. So it snoops the cache again, gets the new modified value, puts it in here as shared. This guy comes back to shared, and we're all good. I believe that's roughly what happens. Like I said, don't know mezzi worth a darn. So basically, you will have to go read about it if you want the actual set of steps that goes in there, but it's something along those lines. So invalidating the cache is that step where you had a value you could have used, but then it became invalid because somebody else wrote to the line behind your back, right? Could you summarize what you did tonight? Found it a little hard to follow along. Yeah, so what we did tonight was really, really straightforward. It just involved a lot of typing. Previously, what we were doing is here is our render buffer. Previously, what we were doing is we were saying, okay, we're going to push in, essentially a transform. We call this the entity basis. And then we were going to pass in, bitmap records. And these are just records that say, what's the bitmap to draw and whatever. And these guys would refer to some basis, right? Then when we actually went to render, we would combine these two at render time and say, okay, at render time, figure out where the bitmap is by using the basis we pushed on before, which is like a transform thing, and the actual offset and stuff that we stored in the bitmap, and produce, an actual position in an actual rectangle in space on the screen. It's like here. This is where the bitmap actually happens, right? That's what we were doing. What we changed to doing is saying, let's not do that anymore. Let's have the render group, so here's the render group, store a transform in it that's whatever the current transform is at the time. And then the render buffer, the sort of the push buffer, right? Instead of ever pushing on these bases, it just pushes on bitmaps. And at the time when the bitmap is pushed on, it does this operation here, the actual, like, whatever you want to call this operation where we do the transform, it does it right at the push time, and then just stores the result of this instead of storing all of the data needed to reconstruct it. So I just wanted to get that done for efficiency purposes. I wanted all of the transforms to happen there. So that's all we did, is change from a delayed transform to a push time transform. That's it. Can you explain what is meant when one says something is done serially? Sure. Serially means that things have to happen in order, right? They have to wait for each other, right? So if I have, here are my steps. I have A, B, C, and D. Here are the ways I could do that. Serial would be A, B, C, D. And these would happen at various times. This is time equals 0, time equals 1, time equals 2, time equals 3, right? They happen. Parallel is the other way, not serial. And what happens there is I have time equals 0, A, B, C, and D, if they were happening in parallel, can all happen at the same time. Now, maybe they don't all complete at the same time. Maybe some take longer than others. But the point is they can all start at the same time. They don't have to wait for each other, right? Whereas here, and I probably should say time equals 0, time equals A plus B, time equals A plus B plus C, right? Meaning D won't start until all of A finished, all of B finished, and all of C finished in order. So A can't start, so A starts, then B has to wait for A to finish before it can start, then C has to wait for B to finish, which means it also had to wait for A to finish because B couldn't start till A finished, and blah, blah, blah. So this takes a lot longer because each thing has to wait for each other. Whereas parallel, one way to say it is serial takes the time of all the things added up, right? Whereas parallel takes the maximum of whatever the times were, right? So whichever one takes the longest is the amount of time that a parallel thing would take, right? I missed a bit of the stream after you removed scale. Didn't you use that for scaling by Z? So yeah, we just didn't need to store it anymore. So we preserved it, pseudonym. We preserved it in, where is it? In here. So the render transform sets the scale, and then it never gets stored in the actual render buffer ever. What happens is at the push time, we compute what the scale is at push time and then just store the dimensions pre-scaled so that we don't have to keep scale anywhere. So when we compute this scale, like you can see in here, when we do a push bitmap, we do the scale right in here, right? And everything does get scaled. P gets scaled as well, but like we store the P, right? So we just don't store the scale anymore because we don't need it anymore after we've pushed the value. We just bake everything in. What's happening between staircase passing and the bitmaps? It is simple scaling based on the z-axis. Yeah, so I think what I did here, and I have to, again, we go back and forth on this so many times, and it's the 2D art thing. It's always hard to really know what the right thing to do is, but get entity basis p, where is that? Get entity, render entity basis p. So when we were doing this, right, and we pass in that offset, I think the thing is the p-value actually shouldn't offset this z, right? I think is what we want. So like original p, if that makes sense, original p's z offset should only be taken into account to move the xy, to move the y of the guy, or something absurd like this. So I think, you know, what we wanted, if this makes sense, is this. Right? To knock out that z value, and then after the p transform happens, right? After the p transform happens, we would take the scale, I guess, and we would add the scale in. So in addition to the projected xy, right, we would add additional y based on that p-value. So it's you know, I want to say it's something like this, result.scale times original p.z, right? So it's going to go up. I don't know if that's correct, but I feel like that's, so you can kind of see like how that's working now, right? So I think that's more what we want, potentially. So yeah. So the problem with that is when we do that, obviously, you know, stuff's z-value, the z-value for the offset isn't really baked in, so I don't know. I mean, we gotta kind of think about this. This is the offset z, right? And so I think what we probably want to do is just do it this way, and for now set the offset z to 0, and then we'll have to play around with how we want to push that. Maybe we'll do that tomorrow. So basically what we want at the moment is to kind of do this just, I think, just like, yeah, just as we were doing it, where we don't really, why am I still, I'm still getting, why am I still getting some, I feel like I'm still getting some roll offset there. Don't you think? Felt like I was still getting some roll offset there. Now that may be fine. All right, well, we can think about it later. How many FPS is this running at? We're running at 60 right now, locked. If I actually compile ourselves in optimized mode, so it's pretty sweet, actually. Our ground chunk rebuilding is not on a separate thread yet, although we could do that pretty soon. So we do have some hiccups, like if I move to a new location, so you get the hiccup there. So we have to fix a couple things, but we're pretty good. To make the 3D appearance of the staircase, will you have to make render technique to draw the walls of the staircase to start from the bottom floor and end at the top floor, creating a cool parallax effect? I don't know. Like I said, I don't know what we're going to do. We'll do something. When do you consider consulting other programmers? Where's the threshold? I usually consult other programmers if I know somebody is an expert in something that I'm curious about, right? That's usually when. I don't usually consult other programmers to just talk about some programming thing because I'm usually fine to just program it myself. But when I'm like doing some multi-threading code and maybe I don't feel like I'm an expert in this particular thing about multi-threading or whatever because I don't do it that much, I might ask someone who I know does a lot of multi-threaded programming who's a good programmer and say like, you know, what do you do about this, or how do you tend to think about these problems, you know, so I can gain some insight there. I'll do that even if I'm not working on it though. Like I also just will tend to ask people how they do stuff in general if I know that they're good at something, because it's, you know, then I'll just know for later. What happens if you want to apply different transforms or lighting to different parts of the scene? We're already set up for that. Basically, all you do is as you go through things. Well, in fact, we already are applying different transforms. We're applying a different transform to every entity actually already. So you could trivially do it to different parts of the scenes if you wanted to. Like right now, so you can see transform.p. Right now, we're setting the offset to wherever the entity is for every entity, but you could trivially do anything you want here. You could set the focal length differently for every entity or anything else you wanted, right? So that we already allow all that. What do you expect will be the boost using OpenGL D3D for blitting? Well, I mean, there's a lot more hardware on there for copying memory around, and it's set up for that, right? So it should be able to do our texture stuff faster than we are. So I'm not sure what you mean. Or do you mean for just blitting our bitmap to the screen? If you mean just bitting our bitmap to the screen, I don't know. It'd probably just be a little smoother because we're not going through a weird path or anything, but I don't know. Is there a concept of local space, model space, camera space, clip space in the render that is analogous to the kind of transformations and APIs such as OpenGL D3D would want? So OpenGL and Direct3D don't have any of those. Actually, they only have clip space. They don't have local space, model space, or camera space. OpenGL and Direct3D are now, they allow you to do all of your transforms and stuff like that in the shaders, so you are in complete control of all of that. So the only thing they really care about is clip space, and clip space we don't really have. I mean, we sort of have it in the sense that when we do the entity get basis p thing, we have it's right here, right? But we aren't ever explicitly actually computing things in clip space because we don't have to. Whereas OpenGL Direct3D need to put things into clip space first. But local space, model space, and camera space are not things that OpenGL Direct3D ever care about or do anything with. Those are all things that get pre-multiplied together into some values that you will submit to your shader. And OpenGL and Direct3D don't care about any of them or even think about them. This isn't related to the stream. I found a video where you explain quaternion double cover, but there is no intro to quaternions, and I could really use a good one. Would you consider doing that in the recent future? No, probably not. I haven't worked with quaternions in a long time, and so I don't feel like I'm probably the right person to give an explanation of them now, especially since there's been a bunch of things that have happened since when I originally did all the work with quaternions. They were very new when I did work with them. Well, new to computer graphics. They were not new. I mean, Hamilton had them under control a long time ago, so they were not new in mathematical sense. So yeah, the landscape has changed. Like there's they do dual quaternion stuff now and other things, and I don't really know anything about that. I've never studied it. I feel like a good intro to quaternions probably also includes some geometric algebra stuff, and I don't really study that either, so it's not really my thing. All right, let's finish it up, folks. Let's finish it up. I'm going to go ahead and close this down. Save that. Takes a long time to save Mischief now. How big is it? Handmade. I guess it's archive. Where is that blackboard? Days. 6 megabytes. That's a lot of drawing we've done. We've done 6 megabytes of drawings, folks. All right. Enough about that. Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along at home and you want to copy the source code, you can go ahead and pre-order the game at handmadehero.org, and it comes with the source code. So you can check out all the day's source and follow along and all that sort of stuff. And you can download it every night. I upload it after I finish programming here, so you can always be up to date as well. If you just want to support the video series, we do have a Patreon you can subscribe to. It's always much appreciated. We also have a forum site that you can go to and ask questions or get ports to Mac and Linux, look at an annotated episode guide, good stuff like that. We have a Tweetbot. The tweet has the schedule. It basically tweets the schedule every weekend, and it tweets the schedule like sort of a coming up soon kind of announcements on every day that the stream is there. So if you're trying to follow the stream live, it's a good way to always know when it's going to be. And finally, we have the Live Now button, which will actually show a countdown timer to the day's stream if there's a stream on that day. So you can also use that, if you're trying to figure out how long it's going to be. All right, so thanks everyone for joining me. I'll see you back here tomorrow, same time, same place. And we will sort of go and maybe start to clean up our pixel-texel coordinates. That needs to happen. So we'll probably go ahead and do that tomorrow, or try to do that tomorrow. So thanks everyone for joining us, and I will see you tomorrow.